Welcome back. We're now going to find the vertex using the formula negative b over 2a. We can use the same quadratic functions, but sometimes it's easier to use this formula. Once we have the vertex value negative b over 2a, the x value for that, then we can substitute that value into the function itself to get the output, or the y value. So let's do this process using the function f of x equals negative 2x squared minus 4x plus 6. First, we're going to label this as part 1, find the vertex. Using the formula given, negative b over 2a, we can substitute the values we have. Negative b would be 4, and 2 times a, where a is negative 2, gives us the final value, negative 1. Now we're going to find the y-coordinate. So we'll substitute negative 1 into our function given, which will give us negative 2 times negative 1 squared minus 4 times negative 1 plus 6. Now I simplify. This gives me negative 2 plus 4 plus 6, or an output of 8. Now I can write my vertex coordinate, which is negative 1, 8. If we want to find the axis of symmetry, we simply look at the first value in our coordinate point for the vertex, and that is x equals negative 1. Now we need to find the x and y intercepts. We can do this using information that we have from previous examples in previous assignments. For the x-intercepts, we're simply setting the function equal to 0. So that gives me negative 2x squared minus 4x plus 6 equals 0. And now I can factor out a negative 2, which gives me negative 2 times x squared plus 2x minus 3. Factoring further, I get negative 2 times x, and x will be the first terms of my binomials, plus 3 and minus 1 will be the other terms in my binomials. And now I can see that my two intercepts will be at 1 and at x equals negative 3. So we have x equals 1 and x equals negative 3. And my y-intercept is simply when all the x's equal 0, and see that my y-intercept will be at 6. We could write this as coordinate points. So I'll just write y equals 6 now, but know that you could write this for x-intercepts at 1, 0, 3, negative 3, 0, and 0, 6. Those are the coordinate points for all the critical values that they're asking. Now we need to graph the function. We have a vertex at negative 1, 8. We have an axis of symmetry at negative 1. We have x-intercepts at 1, 0 and negative 3, 0. And we have y-intercepts at 6. And we could say 0, 6, because 0 in the x direction, 6 in the y direction. And now we just draw the parabola as best we can. Let's try a few more. We need to find the x and y intercepts of each function. If no x-intercepts exist, state this. So finding the x-intercepts for both. we could use the quadratic formula, or we could see if it would factor. Let's see if we can factor out a 2 here. That'll give me x squared minus 2x plus 3. And then if we factor that further, we'll have an x for both binomials, a negative 3. Let's see, that doesn't appear to be working. Let's find out where our vertex is sitting. Our vertex is at negative b over 2a, which will be at 4 over 2 times 2. This is equal to 1. If our vertex has an x value at 1, let's see what f of 1 will equal. This will be 2 times 1 squared minus 4 times 1 plus 6, or 2 minus 4 plus 6. This gives me an output of 4. So my vertex is at 1, 4, and looking at the quadratic function, we know that it's opening upwards. That means the vertex is at a minimum, and there is no real solution to this quadratic. So if no x-intercept exists, state this. Now let's try the next one, x squared minus 4x plus 5. Let's find the vertex, just to be sure we know what we're doing. So negative b would be 4 all over 2 times a, which is 1, will give me 4 over 2, or just plain 2. If we find g of 2, this will be 2 squared minus 4 times 2 plus 5. Or 4 minus 8 plus 5. This is equal to 1. My vertex is at 2, 1. We know that this function is opening upwards because the leading coefficient is positive. So our function will be in the first quadrant at over 2 up 1, opening upwards. So we will have no x-intercepts. But we will have y-intercepts for both of these. So the y-intercept is always the last term in the quadratic. So y-intercept at 0, 6 for the first one, and y-intercept at 0, 5 for the second one.